Hi everyone. In today's class, we'll be treating kinetic theory of gases. I'm very certain that you must have done this in your chemistry. Now, don't mix. They are a little bit similar, but they're not entirely similar. There are still some aspect of it that are actually quite changing. Because for chemistry is more like prioritizing um, the um, the chemical component of the substance. Why physics is dealing with the more like the physical component of the substance. So now, what is kinetic theory of gases? Now, kinetic theory of gases basically explains the three microscopic property of a gas in terms of what the microscopic nature of atoms and molecules making of the gas. Now, usually the physical properties of the solid and liquid can be described by their size, shape, mass, and volume, etc. However, when we talk about gases, they have no definite shape, size. Why? They have mass and then they have volume, but then their volumes and their masses cannot be measured directly because of the spaces between the molecules. As I explained when we talked about states of matter. Now, in the help of kinetic theory of gases, we're able to determine or to measure to determine the physical properties of gases using the three measurable microscopic properties, which are the pressure, the volume, and then the temperature. Now, so what is kinetic theory of gases? And then let's state what the kinetic theory of gases is. So the kinetic theory of gases, so you have the theory itself is under certain segments, it's talking about certain properties of substances. Now the first one is like the component of that particular substance, which are the particles. So for the first kinetic theory of gases, it states that what the gas is a collection of large numbers of atoms or molecules. So what it's saying is that gases are made up of like small particles, a lot of small particles. And then the other aspect of it, talked about what the masses. It talks about the fact that their masses are negligible, like they are negligible, like they are very small. Very small. And then it also talk about their volume as well, so that the volume occupied by a gas molecule or gas particles is negligible compared to the general volume of the container. So when you compare the volume that the gas itself that is present in that gas container is the volume of that gas gas particle is very small. Like it's like 10 times 10 raised to power minus like very small. And then he talked about the force of attraction between the gas molecules. Now the force of attraction between the gas molecules is like is negligible, which is one reason why they can space out. Assuming the force of attraction between them is like very huge, then they will be more tightly packed together like that of solids. And then he talk about the motion. Now the motion followed by a gas particle is haphazard. What that means is like it's random. They don't follow a certain pattern. And aside from that, they collide with the walls of their container and with themselves. And then that particular collision between the wall of their container and themselves is perfectly elastic. So that means the moment they hit each other, they bounce back. Okay, we're going to talk about the volume. We just say that the volume that they occupy is like negligible compared to like the total volume of the container. So then the part about the kinetic energy and the temperature. Now the kinetic theory of gas states that was the average kinetic energy, the temperature of the gas is proportional to the average kinetic energy of its molecule. What that means is that when you sum up all the kinetic energy possessed by the gas molecule inside that gas container, it will be proportional to the temperature of that gas container itself. So that's basically what that is talking about. And then for the pressure, the collision of the particles in the world of gas, is that a force? So for the pressure, you said that the gas molecule possess kinetic theory, they possess kinetic energy. So that means they will have motion. So for them to have motion, that means they are always moving. And we said that their motion is also what, random. They don't follow a particular pattern, they don't follow a particular orientation. So all that means is they keep eating themselves and keep eating the wall of the container. Now they are going to eat themselves and the wall of their container with a particular force. And don't forget that they are acting that particular force on a particular area. Anything like force over area is what is pressure. So that's one reason why it was what pressure deals with the gas, because they are constantly colliding with themselves and with the walls of their container. And that particular pressure is proportional to the frequency, like how much they are actually like bombarding the wall of their container, how much they are actually bombarding themselves as well. So let's now state more like basically what we just did now is just talk about certain physical properties, of gases, and then we more like try to understand them using the kinetic theory of gases. Now let's not state what the kinetic theory of gases, the postulate of the kinetic theory of gases. The first is gases consist of a large number of tiny particles, atoms and molecules. Now these particles are extremely small compared to the distance between the particles. We already said this before. Now the size of the individual particles is considered negligible, and most of the volume occupied by the gas is empty space. Now number 2, a second theory, the second postulate. Now the gas molecules are in constant random motion, which results in colliding with each other and with the walls of the container. Now as the gas molecule collides with the walls of a container, the molecules impact somewhat momentum to the walls. Now this results in production of a force, and since that force is acting on a particular area, then it leads to to the pressure, as I already defined before. Now the third, the collision between the molecules and the walls are perfectly elastic. That means when the molecules collide, they do not lose kinetic energy, they usually just bounce back. Now molecules never slow down and we stay at the same speed all through. So the next one, now the average kinetic energy of the gas particles changes with temperature. So that means when you increase the temperature, the average kinetic energy of the gas particles also change. So the higher the temperature, the higher the average kinetic energy of the gas particles. Now the next one, the molecules do not exert any force of attraction or repulsion on one another except during collision. So those are the theories, those are the postulates of the kinetic theory of gases. And there are some gas laws that this theory will actually allow us to actually understand them better, and it's very important for you to actually understand them a lot. So let's start with let's start with the first one. Now, pressure is proportional to the amount or number of particles at constant volume. So it said the collision of the particle on the walls of the container creates pressure. Now, the larger the number of the particle or the gas, the more the number of particles colliding with the walls of the container. So, at constant temperature and volume, the larger the amount of particles, the higher the pressure. So, basically, this is more like isolating the relationship between the pressure and the number of molecules. Now the more number of molecules that you have, the greater the pressure, because now you have more, don't forget that I said that those particles will be colliding with themselves and with the wall of their container. So imagine normally you have 3 particles colliding with themselves and with the wall of the container. Now you increase it to like 10. Now you have more particles colliding now, so that means there will be more pressure build up within the container. I hope you get that. So now the next one, Avogadro's law. Now Avogadro's laws, there's a song that I recently used. Avogadro's law. So we pay equal volume of all the gases at the same temperature and pressure contain the same number of molecules. So what this is saying is that when there is a great number of particles, it increases the collision and the pressure. Yes. And if the pressure is to remain constant, the number of collisions can be reduced only by increasing the volume. So what is saying is that naturally, when you increase the number of particles, the pressure will increase because the number of collisions increased. So in order for you to actually maintain the pressure, you have to increase the volume so that you space them out. Now it's like you have 5 cm cube. Before, you have like 5 particles in that 5 cm cube. Now you now increase it to 10. So in order for you to actually maintain the pressure that was in the container before, you have to expand the space so that they have more air to breathe. I hope you get that scenario. So that's what Avogadro's number is saying. So that means the relation between the volume and the number of particles as well too at constant pressure. Now then Boyle's law. Now Boyle's law states that what the pressure is inversely proportional to the volume of the gases, provided that the temperature is constant. Provided that the temperature is constant. Boyle's law states that at constant temperature, the kinetic energy of particles remains the same. Because when we talk about the kinetic theory of gases, we said that was the average kinetic energy of the particle of the gas particle is proportional to the temperature. Now, if the volume is reduced at a constant temperature, then the number of particles in units per volume or area increases. Now, if there is increased number of particles in the area, then it increases the frequency of collision. So Boyle's law is more like relating the pressure to the volume, such that when you increase the pressure, to increase the pressure you have to reduce the volume. You are compressing the volume. So when you reduce the pressure, when you increase the pressure, in order to increase the pressure, you have to reduce the volume. I hope you get, so that they will be more tightly packed, so that they will be like the number of collision will increase, because you've compared to when you have like a huge space for them to actually move around, the chance of them colliding will be very small. But now you've reduced that space, so there is no like you have 2 people in a room. They might not even talk to one another. They might not collide with one another. But then if you now increase it to like 100 people in a room, you know that there is no there's no way they won't collide with one another. There's no way they won't actually like associate one another. So that's what the Boyle's law is talking about. And there's a graph that relates to it. And this is the graph. P is in Pascal, V is in meter cube. So this is 1 over V, sorry. One over V. So you have a straight line. But if you don't have that, if you have something like this, PV, then you have something like this. Okay. Now going back. So now we have pressure law. Now pressure law basically just leads what pressure to temperature. It says that what the pressure is proportional to the temperature. That's basically what pressure law is saying. At constant volume. Now take note that when you are saying okay, this is proportional to this one, the other parameters must be constant, because if you don't keep them constant, they will affect they will affect those properties. So if you are dealing with just two, pressure and volume, then temperature must be constant. And therefore you know the effect of that stuff. So pressure law basically just says that what the pressure is proportional to temperature at constant volume. And then we have Charles law. Charles law says that the volume of the gases is proportional to the temperature of the gases. So if you increase the temperature of the gas molecule, they will collide with one another. And in the process of colliding with one another, in order to maintain the pressure, they will expand. They will hit the wall of the container and then they will expand. So that's what Charles was saying. Just saying that the volume is proportional to the temperature at constant pressure. And then we now have Graham's law of diffusion. Now Graham's law of diffusion states that the vapor density, what am I saying? Sorry, the velocity of a what's called what Graham's law is saying. Graham's law is saying that the velocity of the rate of diffusion of a gas molecule is proportional to the square root of its molecular weight. That's what Graham's law is saying. It's saying that the velocity of a gas particle is proportional is inversely proportional to the square root of the molecular weight, as you can see there. And you see the way they derived the remaining formula. So that's basically what you actually need to like know. Those are the laws, those are the gas laws that you actually need to take note. And the reason why we are able to like get to this gas laws is due to the kinetic theory of gases, and allowed scientists to actually be able to find the relationship, because we are in kinetic theory of gases. They talked about basically three parameters: pressure, volume, and temperature. And basically what they are just doing, all these laws, all these gas laws, is just trying to like test the relationship between those parameters and some of those other parameters that are actually dependent on them. Now all these laws, all these kinetic theory of gases are based on the fact that we are assuming that those gas molecules are ideal. That means when those gas molecules are ideal, then they will follow all these laws. But then in real life, they are not ideal. So you should take note that in real life, the gas molecule might not be an ideal gas. And all gas molecule obeys the ideal gas law only under special conditions. Now, in that, for you to actually make those non-ideal gas to not be ideal, you must have what low pressure, and then you must have what high temperature. Those are the conditions required for you to make for a gas molecule to obey the gas laws, the ideal gas laws. And the derivation of the real gas laws of the real gases from the ideal gas behavior is traced mainly to wrong or incorrect assumptions in the postulate. Now, those wrong postulates are: now the particles are point charges and have no volume. That's wrong. They have volume. When it should be possible to compress the gases to zero volume. Let's go over that again. So those wrong postulates are these. They said the particles are point charges and have no volume. Now, if this is true, then that means that we should be able to like compress the gases to zero volume. And when they perform those experiments, they realize that it's impossible for a particular gas to have a volume of zero. It's impossible. So that means each of those gas molecules or each of those gas particles must have its own volume. So that means that this particular postulate is what is wrong. Now the second one: particles are independent and do not interact. That's wrong as well too, because we already know that from the kinetic theory of gases that gases collide with one another. They bounce on each other. They collide. They don't form they don't have strong intermolecular forces, but then they interact with one another once in a while. They collide. And then the last one is what the particle collisions are not elastic. They are inelastic, and we already know that they are elastic because they don't stick to one another when they collide. They bounce off each other and then they move on. So those are that's the gas laws and the kinetic theory of gases. So I want you to do me a favor. Don't do me a favor. Do yourself a favor. Draw the graph the same way I drew the graph for the Boyle's law. Draw the graph for Charles' law and the pressure law, and then we have the general gas law. For general gas law basically combines all the gas laws together, so that you have what pressure, volume, and temperature. You have what PV over T proportional to equals to K. So this is the general gas law. Now then we have the ideal gas equation. The ideal gas equation, this is general gas law. Don't mix it up. General gas law. Now for ideal gas equation is one that has what PV equals what nRT, where your P is your pressure, your V is your volume, your N is your number of molecules, your R is your gas constant, and then your T is your temperature. This is the ideal gas equation. So that's all, guys. See you guys in my next class.